Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve a differential equation using variation of parameters method part 2. So we are going to solve the given differential equation using another way. Let's get going. Problem. Solve y double dash minus y equals to 1 plus e power minus x raised to the power minus 2 or d square minus 1 into y equal to 1 plus e power minus x raised to the power minus 2 using variation of parameters method. So here we are given a differential equation of order 2, right? Y double dash minus y equal to 1 plus e power minus x raised to the power minus 2. We can write y double dash as d square y by dx square minus y equal to 1 plus e power minus x raised to the power minus 2. And we can write d square y by dx square as capital D square y minus y equal to 1 plus e power minus x raised to the power minus 2. Now take y common from these two terms, we'll get d square minus 1 into y equal to 1 plus e power minus x whole square, which is in operator form. So we have written the first equation in operator form. So both the equations are same, right? Consider the first equation as equation 1 and the equation in operator form as equation 2, which is in operator form. So f of d into y equal to some function of x, where f of d equal to d square minus 1 and r of x equals to 1 plus e power minus x power minus 2. Okay, and the homogeneous equation of 2 is d square minus 1 into y equal to 0. Consider as equation 3. Now we'll find the solution of equation 3 using the auxiliary equation, and later using solution of equation 3 we'll find the general solution of 1 and 2. Right? Now coming to RHS. RHS equals to 1 plus e power minus x raised to the power minus 2, right? We have r of x equals to 1 plus e power minus x raised to the power minus 2. Okay, we can write it as, since e power minus x is reciprocal of e power x, so just replace e power x with 1 by e power x. We'll get 1 plus 1 by e power x raised to the power minus 2. Now take the LCM of these two terms, we'll get e power x plus 1 by e power x raised to the power minus 2. This is equals to e power x plus 1 power minus 2 by e power x power minus 2. Since we know that e power x power n equal to e power n into x, so we can just write e power x raised to the power minus 2 as e power minus 2x. Okay, now split this fraction as 1 by e power minus 2x into e power x plus 1 raised to the power minus 2. We know that reciprocal of e power minus 2x is e power 2x into, and we can write e power x plus 1 raised to the power minus 2 as 1 by e power x plus 1 whole square, since x power minus n equal to 1 by x power n, right? Or some a power minus n can be written as 1 by a power n, right? Then for a equal to e power x plus 1, we'll have e power x plus 1 whole power minus 2 equals to 1 by a power minus 2, right? Then this becomes e power 2x by e power x plus 1 whole square. Therefore r of x equals to 1 plus e power minus x raised to the power minus 2 equal to e power 2x by e power x plus 1 whole square. Okay, fine. Now let's find the solution to our homogeneous equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 1. Let's replace differential operator d by m, so that we'll get f of m equal to m square minus 1. Now the auxiliary equation becomes m square minus 1 equals to 0. We can write 1 as 1 square, so that the LHS will be of a square minus b square form, and we can write it as a plus b into a minus b. Now just equate each factor to 0. From m plus 1 equals to 0, we'll get m equal to minus 1, and from m minus 1 equals to 0, we'll get m equal to 1. So m equal to minus 1 and 1 are the roots of our auxiliary equation. Therefore, the roots are real and distinct, right? We know that when two roots, say m1 and m2, are real and distinct, then the solution of homogeneous equation looks like y equal to 1 constant into e power 1 root into x plus another constant into e power another root into x. So here I'm taking C3, C4 instead of C1 and C2 or anything else, because I want C1 and C2 to appear in the last general solution, right? Now let's write the homogeneous equation solution, the solution to homogeneous equation. The solution of homogeneous equation is given by y equal to 1 constant into e power 1 root into x plus another constant into e power another root into x. Then we'll get y equal to c3 e power minus x plus c4 e power x, which is the solution to our homogeneous equation. Now using this, we'll write the solution, the general solution to our problem, equation 1 and 2. Just by replacing the constants or parameters with functions of x, we can find the general solution of our problem. Let y equal to a e power minus x plus b e power x be the solution of, general solution. One and 2. Just replace the constants or parameters with functions of x, a and b, where a and b are functions of x. Here we can compare the solution, this solution, with y equal to c3u plus c4v, or this with y equal to au plus bv, so that we'll get u and v, where u is e power minus x and v is e power x. Right? And we'll find a, b using a dash equals to minus v into r of x by uv1 minus vu1, and b dash is given by u into r of x by uv1 minus vu1. If you observe both the formulae, we have uv1 minus vu1 in both the formulae. So let's begin with uv1 minus vu1, and later on we'll find a dash, b dash, a and b. U into v1 is nothing but derivative of v with respect to x, minus v into u1 is nothing but derivative of u with respect to x. We have u e power minus x into derivative of v with respect to x minus v into derivative of u with respect to x. This gives us e power minus x into derivative of e power x with respect to x is e power x, minus e power x into derivative of e power minus x with respect to x is minus e power minus x. This gives us e power minus x into e power x, minus into minus plus e power x into e power minus x. Okay, we are having e power minus x into e power x in both the terms, right? We can write it as 2 e power x into e power minus x, right? Or e power x into e power minus x can be written as e power minus x is reciprocal of e power x, so you'll get 1 by cancelling e power x, right? So you can just replace e power minus x and e power x with 1, so that you'll get 1 plus 1, which is equals to 2, or you can replace it here. Okay, therefore uv1 minus v1 equal to 2. Or just add the powers, you'll have e power x minus x, which is e power 0, since e power 0 is 1. So you'll get e power x into e power minus x equals to 1, right? So we got uv1 minus v1, which is 2. Let's now find a dash a, b dash b. A dash is given by minus v into r of x by uv1 minus vu1. Then a dash equals to, see, we're having r of x is a fraction, right? So we'll write the formula as minus v by uv1 minus vu1 into r of x for our convenience. This gives us minus v is e power x by uv1 minus v1 is 2 into r of x is e power 2x by e power x plus 1 whole square. See, it is easy, right? You can write it as minus e power x into e power 2x by 2 times e power x plus 1 whole square minus e power x into e power 2x is, at the powers you'll have e power x plus 2x, which is equals to e power 3x. This gives us e power 3x by 2 into e power x plus 1 whole square, or minus 1 by 2 into e power 3x by e power x plus 1 whole square. Therefore, a dash equals to minus 1 by 2 into e power 3x by e power x plus 1 whole square. From this we can find a. Let's now find a. We have a dash equals to minus 1 by 2 into e power 3x by e power x plus 1 whole square, right? And we can write a dash as, or a dash is nothing but derivative of a with respect to x, equals to minus 1 by 2 into e power 3x by e power x plus 1 whole square. Now take the differential dx to RHS in order to separate the variables. We have dA equals to minus 1 by 2 into e power 3x by e power x plus 1 whole square into dx. So here variables are separable. So we can perform integration. Integral dA equal to minus 1 by 2 integral e power 3x by e power x plus 1 whole square into dx. Let e power x plus 1 equals to t. Now differentiate on both sides with respect to x. We'll get derivative of e power x with respect to x is e power x plus derivative of a constant with respect to x is 0 plus derivative of t with respect to x. This gives us e power x equals to dt by dx. From this we'll get e power x dx equals to dt, right? So we can replace e power x dx with dt and e power x plus 1 with t, and also e power x can be replaced with t minus 1. If you take this 1 to RHS, we'll get e power x equals to t minus 1. Now let's say split e power 3x as e power 2x into e power x by e power x plus 1 whole square into dx, so that we can replace e power x dx with dt and e power x plus 1 with t, and here you're having e power 2x, right? e power 2x can be written as e power x whole square. Since we know that e power nx can be written as e power x whole to the power n, right? And here we have e power x equals to t minus 1, so that we'll get e power x whole square equals to t minus 1 whole square. So in the next step we can replace e power 2x with t minus 1 whole square and e power x dx with dt and e power x 1 plus whole square with t square. Okay, let's write one more step. We can write e power 2x as e power x whole square by e power x plus 1 whole square into e power x dx. This gives us integral dA equal to minus 1 by 2 integral e power x can be replaced with t minus 1, so you'll get e power x whole square as t. Just replace e power x with t minus 1, you'll get t minus 1 whole square by replace e power x plus 1 with t and replace e power x dx with dt. Okay, so you're having t minus 1 whole square by t square in the integrand. We can write it as t square plus 1 minus 2t by t square. Since we are having 3 terms in the numerator and 1 term in the denominator, so we can split this into 3 terms. We'll get t square by t square plus 1 by t square minus 2t by t square. T square gets cancelled, you'll get 1 plus 1 by t square minus 2 by t, or 1 plus 1 by t square minus 2 into 1 by t. Just replace the integrand with 1 plus 1 by t square minus 2 into 1 by t, since t minus 1 whole square by t square equals to 1 plus 1 by t square minus 2 into 1 by t. This gives us integral dA equal to minus 1 by 2 integral of, replace t minus 1 whole square by t square with 1 plus 1 by t square minus 2 into 1 by t into dt. This gives us integral dA equal to minus 1 by 2 of integral 1 into dt is dt plus integral 1 by t square dt minus 2 integral 1 by t dt, right? Just write 1 by t square as t power minus 2 here. From this we'll get integral dA a equal to minus 1 by 2 of integral dt d plus integral t power minus 2 dt is t power minus 2 plus 1 by minus 2 plus 1 minus 2 into integral 1 by t dt is log mod t plus integral constant says c1. Okay, or we can write it as a equal to minus 1 by 2 of t plus t power minus 1 by minus 1 minus 2 log t plus c1, or a equal to minus 1 by 2 of t minus 1 by t minus 2 log t plus c1, right? Now we can replace t with e power x plus 1, since t equal to e power x plus 1, then a becomes minus 1 by 2 of, just replace t with e power x plus 1, you'll get e power x plus 1 minus 1 by e power x plus 1 minus 2 log of e power x plus 1 plus c1. Therefore, a equal to minus 1 by 2 of e power x plus 1 minus 1 by e power x plus 1 minus 2 log of e power x plus 1 plus c1. We got A. Let's now find B dash and B. B dash is given by u into r of x by uv1 minus v1. Here you're having r of x, which is a fraction. So for our convenience, we'll write the formula as u by uv1 minus vu1 into r of x. And b dash is nothing but derivative of b with respect to x. This gives us db by dx. Sorry, let's write b dash. Firstly, we need to find b dash, right? This gives us u e power minus x by uv1 minus v1 is 2 into r of x is e power 2x by e power x plus 1 whole square. This gives us e power minus x into e power 2x by 2 times e power x plus 1 whole square, which is equals to e power minus x into e power 2x is e power minus x plus 2x. Since 2x minus x is x, so you'll get e power x. Just replace the numerator with e power x by 2 times e power x plus 1 whole square. Therefore, b dash equals to 1 by 2 into e power x by e power x plus 1 whole square. We got b dash. Let's now find b using this b dash. We have b dash equals to 1 by 2 into e power x by e power x plus 1 whole square, right? B dash is nothing but derivative of b with respect to x equal to 1 by 2 e power x by e power x plus 1 whole square. Let's now separate the variables by taking differential dx to RHS. Then we'll get db equal to 1 by 2 e power x by e power x plus 1 whole square into dx. Here the variables are separable, so we can perform integration. Integral db equal to 1 by 2 integral e power x by e power x plus 1 whole square into dx. Let e power x plus 1 equals to some p. Now differentiate on both sides with respect to x. We will get derivative of e power x with respect to x is e power x plus derivative of constant with respect to x is 0 equal to dp by dx. From this we will get e power x equals to dp by dx. Right? Again, this gives us e power x dx equals to dp. Now we can replace e power x dx with the dp, and e power x plus 1 can be replaced with p. Or we can write this as integral db equal to 1 by 2 integral 1 by e power x plus 1 whole square into e power x into dx. This gives us integral db equal to 1 by 2 integral 1 by, replace e power x plus 1 with p, you will get p square. This is square, okay? And e power x dx can be replaced with dp. Now, write 1 by p square as p power minus 2. From this we'll get integral db equal to 1 by 2 integral p power minus 2 dp is p power minus 2 plus 1 by minus 2 plus 1 plus integral constant says c2. From this we'll get b equals to 1 by 2 into p power minus 1 by minus 1 plus c2. This gives us 1 by 2 into minus 1 by p plus c2. Right? This is equals to minus 1 by 2p plus c2. Since p equal to e power x plus 1, from this we'll get b equal to minus 1 by 2 into 1 by, just replace this p with e power x plus 1, we'll just get minus 1 by 2 times e power x plus 1 plus c2. Therefore, b equal to minus 1 by 2 times e power x plus 1 plus c2. So we got b and already we got a. Let's now write the general solution using y equals to a power minus x plus b power x. Therefore, the general solution is given by y equal to a y equal to a e power minus x plus b e power x. Just substitute a and b, okay? We'll get a minus 1 by 2 of e power x plus 1 minus 1 by e power x plus 1 minus 2 log of e power x plus 1 plus c1 into e power minus x plus b minus 1 by 2 times e power x plus 1 plus c2 into e power x. This gives us minus 1 by 2 into e power minus x into e power x plus 1 minus into minus plus 1 by 2 into e power minus x into 1 by e power x plus 1 minus into minus plus 1 by 2 into 2 into e power minus x into log of e power x plus 1 plus c1 e power minus x plus into minus minus e power x or 1 by 2 into e power x into 1 by e power x plus 1 plus c2 e power x. Here 2 gets cancelled and we'll get y equal to minus e power minus x of e power x plus 1 by 2 plus e power minus x by 2 times e power x plus 1 plus e power minus x log of e power x plus 1 plus c1 e power minus x minus e power x by 2 times e power x plus 1 plus c2 e power x. Or we can just write this as, first write the terms involving c1 and c2. Now write the term involving log Now write the remaining 3 terms. I'll write the term involving plus firstly. Plus e power minus x by 2 times e power x plus 1 minus e power x by 2 times e power x plus 1 minus e power minus x of e power x plus 1 by 2. Now I'll simplify these 3 terms, last 3 terms. Okay. Consider this equation as asterisk. Now I'm going to simplify these 3 terms, right? So from the first 2 terms, you can take 1 by 2 e power x plus 1 common. Let's take 1 by 2 times e power x plus 1 common from the first 2 terms. You'll get e power minus x minus e power x minus e power x of e power x plus 1 by 2. Or we can write it as e power minus e power x by 2 times e power x plus 1 minus e power minus x of e power x plus 1 by 2. Now take the LCM of 2 and 2 times e power x plus 1. 2 ones are 2. 2 into e power x plus 1 is e power 2 e power x 2 times of e power x plus 1. E power x plus 1 into 1 is e power x plus 1, right? So our LCM is 2 times e power x plus 1. In the denominator of first term, you're having 2 times e power x plus 1. So you can just write the numerator as it is, but in the denominator of second term you're having 2, so close to you're having e power x plus 1. So let's multiply e power x plus 1 to this numerator. We'll get e power x of e power minus x, right, of e power x plus 1 into e power x plus 1, which gives us e power minus x minus e power x minus e power minus x of e power x plus 1 into e power x plus 1 is e power x plus 1 whole square by 2 times e power x plus 1. Okay. This gives us e power minus x, e power x minus e power minus x of expand e power x plus 1 whole square. We'll have e power x whole square plus 1 plus 2 into e power x by 2 times e power x plus 1. This gives us e power minus x minus e power x minus e power minus x of, we know that e power x whole power n equal to e power nx, then we can write e power x whole square as e power 2x plus 1 plus 2 e power x by 2 times e power x plus 1. This gives us e power minus x minus e power x minus e power minus x into e power 2x minus into plus minus e power minus x minus into plus minus 2 into e power minus x into e power x by 2 times e power x plus 1. See, here we are having e power minus x into e power 2x, e power minus x into e power x. Let's simplify that. E power minus x into e power 2x is equals to e power minus x plus 2x, which is equals to e power minus x plus 2x is x. So you can replace it with e power x, and here you're having e power minus x into e power x. Just write e power minus x as 1 by e power x into e power x. Here e power x gets cancelled, we'll get 1. Just replace this with 1, then this becomes e power minus x minus e power x minus e power x minus e power minus x minus 2 into 1 by 2 times e power x plus 1, right? So here plus e power minus x and minus e power minus x gets cancelled. Minus e power x minus e power x is minus 2 e power x, minus 2 into 1 is minus 2 by 2 times e power x plus 1, which gives us, just take minus 2 common from the numerator, you'll get minus 2 times e power x plus 1. The denominator remains the same. Here 2 and e power x gets cancelled from the numerator and denominator as well. From this you'll get minus 1. Therefore, e power minus x by 2 times e power x plus 1 minus e power x by 2 times e power x plus 1 minus e power minus x of e power x plus 1 by 2 equal to minus 1, right? Since this term is equals to 1, so just replace the 3 terms by minus 1. Okay, the terms under brackets with minus 1, or the term under bracket, whatever. Then the above equation becomes c1 e power minus x plus c2 e power x plus e power minus x log of e power x plus 1 minus 1. Therefore, y equal to c1 e power minus x plus c2 e power x plus e power minus x of log of e power x plus 1 minus 1 is the required solution. So this completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next. Until then, bye bye.